hi everyone, and today we are going to solve this LeetCode daily challenge, making a large array. So this problem is basically of graph, and you want to it is about connected components. So you want to combine like one, two, or four components to form a larger component. Okay. So in this problem, what you can do is, I hope you have already read the problem. Like suppose you have some islands like this, and here it is 0. Then you have, and you also have like this. Okay, so what you can do in this case, you will go to each cell which has 0, and you will ask yourself like, can I switch this cell? If you will switch this cell, what will be the effect? If you switch this 0 cell, you can go to 4 different directions. Okay, left, right, east, left, right, and north, south. So you will check like in the left, is there a connected component? If there is, then what is the size of that component? Similarly, on the top, if there is a component, what's the size? So for each cell containing 0, you will do this, and you will calculate what is the largest element that you can form, and doing that, and you will do this for all the cells with grade of ij equal to 0, and you will find the maximum uh, size. So how I'm going to do this, like if some cell, like if there is an island, I will mark all its consider, let's say that island uh, we will say we'll call the island component. Okay, so take a component, and you will mark all the cells lying in that component with some id. Okay, so I'll say like this is the component with 4 elements, so I'll assign id 1 to each of these cells. Similarly, this is the second component, I will assign id 2 to them. This is the third component, I will assign id 3 to them. And this is the fourth component, I will assign id 4 to it. Now what are the ids adjacent to cell 0? 1, 2, 3, and 4. And what are the sizes of these components? The size of component with id 1 is 4. The size of component with id 2 is 2. The size of component with id 3 is 6. The size of component with id 4 is 3. And also you will switch this 0 to 1 now, so you will count this also. And finally, the largest component that you can form by switching 0 to 1 is 4 plus 2 6, 6 plus 6 12, 12 plus 3 15, 15 plus 1 16. Okay, so this is how we will calculate the largest island that we can form, and we will find the maximum by switching all these grade of ij equal to 0 cells. Also, it is possible that this one was also 1. Like this way, you can see, oh, this way you can see that the component on the left side and component on the top are connected, so they will have the same id. So in this case, you will have ids like this, only 1, 3, and 4, and the size of component with id 1 is 7. Okay, 7, then 6, and then 3, and then you have 1 as well, so the size here will be 70. Okay, so these are the two cases like I used to explain you like how we're going to calculate. Now you just need to write the code. So what I'm going to do is, you will calculate the size of the grid first. You will have a vector of vector which will store the IDs for each connected component. You will also have a vector which will store the component size, and it will be of size 1. So technically I'm saying that component with ID 0 has a size of 0. Okay, and for component with id 1 will have some size. I'm already defining for id 0 because id 0 signifies that this cell is not part of any component. Technically you cannot go to that cell because there is no edge. So like for cell equal to 0, like grid ij equal to 0, we were checking all four directions now. So in one direction it is possible that there are uh, no island or no component is there, so we don't want to consider that part. So I'm taking for that, I will mark 0 in the connected component matrix, and for cell with id 0 we will take the component size to be 0 because there is no component. Okay, something like that. And now we can traverse the grid and find the connected components. Also I will take the count variable to calculate the size of the component. If grid of ij is equal to 0 or grid of ij equal to 1, oh sorry 2. 2 means that I have visited this grid cell. Okay, if grid of ij is equal to 1, this means that there is an island and it hasn't been visited yet, so we will visit it. And you have grid. You will also pass the connected component matrix. You will also pass the component size array and also the count variable. And after this function, the count variable will be containing the size of the component with some id. So you will update this component size array. So this is how it will work. Okay, you can write the DFS also. First we will have a vector of vectors directions to go to the adjacent nodes. And like pass all the parameters. Yeah, now you can visit this node ij. You can also mark the connected component matrix. And you will also count the number of cells in that. Then you will go to the adjacent nodes. If 2 of I is less than 0, which means it is out of the grid. Then you can continue. If grid of ij is equal to 0, this means that there is no edge. Else if grid of ij is equal to 1, then you want to visit it. So we can do 2 of I, 2 of j, and grid connected component size and count. And this is 2 of I, 2 of j, I'm sorry. Also you can take n. So yeah, this is the DFS function. And finally, after doing this, see, there is also a possibility that there are no zeros in the grid. So in that case, the whole matrix is a connected component. So I'll consider that answer as well. So I'll traverse this component size array, which contains the sizes of all components. and I'll pick the maximum size. Okay. After this, we can also do this. If there are zeros in the grid, I'll go to each node, and if grid of ij equal to 0, what I'm going to do, I'll pick the IDs in all 4 directions and I'll store those IDs in this set. So I'll traverse the all 4 directions and I will get 2 of I equal to I plus dir 0 and 2 of j equal to j plus dir of 1, and if 2 of I is less than 0, 2 of I greater than equal to n, then we'll continue. Otherwise, what we can do is we will fill this IDs. Okay, in this set we will have all the IDs. After doing this, you can calculate the value after switch. This will be 1 because that 0 node which we are talking about, that also we have to count when we will switch it to 1. Then you can traverse this set and you can update this value after switch. Sorry, it's not x, it is x is the ID here. So what's the size of that component with ID x? And finally we will maximize our answer. So yeah, so the time complexity of this solution will be O of nm. Okay, so yeah, thank you for watching this video. I hope you like it. Please subscribe to the channel and also hit the bell icon for future notifications. Thank you.